a quadrilateral is inscribed in a circle of radius 200 times root 2. 3 of the sides have a length of 200. What is the length of the fourth side? So this is a geometry problem somewhat, as we can tell, and 90% of geometry is seeing the picture. So I'm going to inscribe a quadrilateral, and I'm using the center as the reference point, center of the circle. And let's see, here we have a so let's make it a different color. Now we have a quadrilateral. There. So we are given a radius of 200 times the square root of 2. 200, so 200 square root 2. And these 3 triangles that I have made, I know that they're going to be congruent. And so let's call the specific angle theta. This will be useful later on. So we know that 3 of these sides have a length of 200. So that green side, obviously not perfectly drawn a scale, but like we're going to say that there are 200 each. So we want to find this side, right? So the first thing I'm going to do is label some points. So let me take out a different color. Sure. I'm going to call this O. I'm going to call this A, B, C, D. Alright, so now what I want to do is solve for the sides of triangle O, B, C. So this thing right here. And we have that angle theta. And in order to solve this, we're going to use our given information and put it towards the law of cosines. So we have BC squared equals OB squared plus OC squared minus 2 times OB times OC times cosine of that angle theta. Alright, so now we know that BC is going to be 200. So 200 squared equals, and so we also know that this is a, it's directly from that radius. So it is a line segment from that radius. So we know that's going to be 200 times square root of 2. So 200 square root of 2, and then 200 square root of 2 as well. These two start from the center and go to an endpoint of the circle. So radius of 200 square root of 2, we're going to plug it in right here. Minus 2 times, so notice what I'm going to do here. So we could write times 200 square root of 2 times 200 square root of 2, but I'm going to write it as a squared term, just to save time, times cosine of that angle, which we still don't know. And I want to solve for that cosine. And so just to save time, after much simplification, we're going to get cosine theta equals 3/4. Okay? So now I want to see what would happen if I took this entire thing, cosine 3 theta. Okay? So I want to find cosine 3 theta, and I'll explain why in a second. Cosine 3 theta. Alright, so this is simply equal to cosine of 2 theta plus, so 2 theta plus theta, which is part of our angle addition formulas. However, I'm simply, just for the sake of time, I'm simply going to give the formula we should obtain at the end, which is, let's see, 4 cosine cube theta minus 3 cosine theta. Alright, so we know that this notation simply means quantity cubed. Okay? So in order to find this, I know that cosine, so we know that cosine theta is 3/4. So I'm going to plug this in. Cubed minus 3 times 3/4. Alright, after simplifying, we should get cosine 3 theta is equal to negative 9/16. Alright, so negative 9/16. Alright, so now the reason we did this is because we want to apply the law of cosines to this big triangle, triangle OAD. So let me highlight it. This section right here, that triangle, we're going to apply the law of cosines to find this remaining side, AD, which would be the answer to our problem. So now we have all this information. I'm going to say, so just by the way, the reason we found cosine 3 theta is because this 3 theta, that angle, represents this entire angle of that whole triangle. So let me redraw it. So this triangle that we're trying to find, and then we have AD, and then O here. So we want to find, so this is 3 theta, and we want to find AD. Okay, so that's the reason we found 3 theta, because it would be the angle of that triangle that we're referencing. So, applying the law of cosines, we got AD squared is going to be equal to OA squared plus OD squared minus 2 times OA times, OD times cosine 3 theta, because that's going to be our angle. And so we know that AD is our unknown, is what we're trying to solve for. OA, based on the given information, is going to be 200 times the square root of 2, quantity squared, and same thing for OD. So minus 2, and again, to save time, 200 square root 2 times 200 square root 2 is simply equal to the quantity squared. And we know that cosine 3 theta is going to be negative 9/16. Alright, so wow, that's a lot of simplifying we have to do, and again, saving time. This is going to be equal to 250,000. Therefore, AD, or missing side, is equal to 500. So our answer would be E.